which has all your applications. So you guys are all familiar with this. And what you're actually doing is you're really sending commands to the website. You're telling it things like, hey, the user clicked the checkout button, or I'd like to submit this title and this body to a forum, or please give me all the information about product ID 24. You don't know how the web server services this request. You don't know when I say, hey, submit this post to a forum. You don't know what database it's contacting in the back end. You don't know what it's doing to the different inputs you gave it. You're really just giving it a big block of text and say, handle this. And that's really key. It's what the web service should do, but you don't tell it how to do it. So how do we attack traditional web applications? Because we're doing it right now. Well, really, the attacks involve sending malformed commands. So we'll submit a post with script tags in it, trying to do a cross-site scripting attack. We'll upload a really bad GIF image or a ping image as our avatar for a forum, trying to corrupt their back-end systems. We'll tell the web app, hey, give me product ID -1. So what we're really trying to do with attacking web applications in this traditional manner is you're trying to hit these edge cases. You're trying to say, I bet the programmer never anticipated it. Excuse me. I was up pretty late last night, so I apologize if my voice is a little scratchy. What you're really trying to do is hit these edge cases that the programmer probably didn't take into account. Maybe the programmer never anticipated a negative product ID. Maybe the web programmer never anticipated having HTML inside a forum post. And this is the interesting thing, because input validation in web applications is how you actually stop these types of attacks. You want to ensure the commands I'm getting from the user are correct. If they tell me, view shopping cart and give a session ID, that session ID better be valid and should be the session ID that I actually issued to that person, so they're not trying to steal somebody else's shopping cart. The input validation really takes place on both the client and the server. Like we showed back here, the attacker can talk directly to the server. I don't have to go through this JavaScript layer. You can browse the internet using Telnet. I mean, you really can. So you can't assume when you're doing input validation that any of the input you're getting from the user has passed through any type of validation. Client-side validation exists solely for performance, because crossing that big internet cloud is expensive. So on the server side, we actually validate, hey, was this negative? Hey, was this actually a zip code? Now, you'd think this would be easy, right? Because I wrote the application. I know what the data type should be. I got a requirements doc. We architected this thing out. I know that I'm only supposed to get ISBNs or something like this if I'm running a bookstore in this field. I know what that format should be. I know what the valid range is. I know what the data type is. If this is a zip code, I know it's not ever going to contain letters. I mean, everything about the input you're receiving is defined. You know what it is. So how secure are traditional web applications? Really, really insecure. I always like to tell this story. There's a major news organization that exists. They're the main news organization, which I guess is not fair and balanced because that's not their slogan. But they have a vulnerability in their one of their news story pages. And so every year on my mom's birthday, I send her a link. And it's a news story with a byline of Bob Woodward saying Mary Hoffman is the greatest mother in the world. And it goes through and proceeds to say, it's like, sources close to the investigation say that she makes a hell of a pancake. And I just proceed to send her this. She has no idea how I do it. She comes up to me, she's like, you didn't hack that news site, did you? I'm like, no. I just injected cross-site scripting, and it rewrote the page and made all this content about my mom really kicking ass. So Gartner, it's fun. I highly encourage people to go out and investigate their own web applications, because there's all sorts of fun things you can find out there. There are also a lot of dangerous things as well. And Gartner is saying that 70% of all attacks now are coming through the application layer. You really got to liken this to a house again. Layers 3 and layers 4, IDSs, firewalls, things like that, they're by no means perfect, but we kind of have solutions to this. It's reasonably difficult nowadays to, be able to telnet to back-end systems. So you think of this as a house, and your IDSs and your IPSs and your firewalls are like putting a really big Schlage lock on your front door. But you've got a web application running as well. And that web application talks to a back-end database. So if I want to extract data from that back-end database, I can try to pick your front lock, meaning get around your IDS, your firewall, things like that, or I can go through your website. And your website, if it's just a window and you didn't properly secure that, it doesn't have bars, it doesn't have anything, it doesn't matter how good of a lock you have on your front door, I'm just going to throw a cinder block through your window and take stuff that way. And so hackers take the path of least resistance, and web apps are the least resistance. You know, you can't read full disclosure, any of the security mailing lists without seeing just a mess of cross-site scripting vulnerabilities, SQL injection vulnerabilities. So as we say, you know, this is where things are going, this is where things are growing, and it just makes sense because hackers are lazy. So the theory here that we've kind of established is input validation should be easy in these traditional applications because we know everything ahead of time. We know data types, we know ranges. The reality is web developers are doing a very poor job of this. You can't go across the internet without stumbling upon ODBC error messages, SQL injection errors. You can't find, I mean, cross-site scripting is everywhere. It's even, it's funny, there's actually a search engine out there. It's not one of the big ones, but if you go looking for cross-site scripting vulnerabilities in their little search dialog, their search dialog box is cross-site scriptable. So if you type in script, alert, whatever, because you're looking for examples of cross-site scripting, you'll cross-site script the search engine trying to find other cross-site scripting vulnerabilities. So they're all over the place. Does anybody have any questions so far? Am I talking too fast? Is this good? All right. Starting to get that late morning kind of lull. All right, so AJAX applications really kind of extend the application to span both the client and the server. You'll see I've drawn this little green line farther down because what we do is, remember, JavaScript is now trapping that input and doing some type of process on it. AJAX is, or JavaScript is making an HTTP request to some web service now running on your server because it can make direct connections. So really what it's doing is it's making function calls in a way. It'll say things like, hey, give me the price for product ID 24. Or, hey, you know, I'm looking at, say, a mail portal, and there's a JavaScript, and every 30 seconds it fires off an AJAX request to find out if I have new mail. Or given the state, return all the valid cities there. Or, you know, hey, database, tell me what the last known address was. What we're really doing is sending to the server how to do what we want it to do. We'll tell it, say, if you're filling in a profile, you know, at a popular social networking site, you're updating, say, your age, your interests. As soon as you know, tab away from those check boxes or something like that, instead of saying submit, some of these social sites will actually, as soon as you leave a text box, we'll use AJAX to go contact the server and say, let's update this attack, or let's update their address, or let's update this checkbox. So if I've got a form with 15 inputs, in a traditional web application, I'd fill in all these 15 inputs, click submit, and then it would go to the server. With AJAX, depending on how they write it, if I have 15 inputs, I could have 15 different web services that are all called on the back end where each one of those little pieces of data are inserted. So you start to see what I'm saying about the attack surface drastically increasing. So what does this mean for the attacker? Well, first of all, the attacker is now inside your application. If you're running things on the JavaScript logic layer, let's say, you know, they fill in this form, let's take all of the input values, create, say, a pipe or a comma-separated list, and then submit it to a web service. You're doing some type of packaging, munging on the back end, and then you're contacting a web service. Well, I now know the function names of that web service. I know the variables. I know the parameters. I know the data types of those parameters. I know valid ranges that your application accepts. Normally, I would need to either crawl your entire application and find all references to this, or I'd need to somehow extract actually the binary business logic from the website and then, you know, run, say, classic, you know, IDA Pro, do classic reverse engineering, trying to figure out what you're doing on the back end. But you're pushing some of this logic to me in the form of JavaScript now, in plain text. And also, your attack surface is increasing, like we said. We can now audit the application's API. All those web services you spawned, the attacker can directly contact them and start trying to screw with them. And really, this is exploiting the trust relationship between the client and the server. I cannot reiterate it enough. You cannot trust anything you receive if on the server side, because the attacker can just directly contact you and submit everything. So really, with an AJAX application, we have 3 types of input now. We have form input, which is what classic web development sites had. You've got, you know, get a form variable with text boxes, you know, radio buttons, text areas, and I can submit this with a get or a post. Validation obviously isn't implemented enough already. I mean, 70% of attacks through the web application layer, and that's been happening for a while. That's not because of AJAX. That's because people aren't very good at securing traditional forms. We've got file formats. You know, I let you upload an image as an avatar for a forum, or, you know, you're able to share zip files with your friends. You know, that's file formats. We saw numerous exploits, obviously the WFM exploit this past winter. There have been a bunch of bugs in the JPEG and PNG image handling libraries. There have been buffer overflows. So you even have to validate that the files you're receiving from the user are of the proper format and aren't going to do something nasty when you actually start processing them. And now, because of AJAX, we've got more and more exposed functions and web services for AJAX to phone home to. I mean, and you know, you've got control logic functions, you know, look this part up in the database. These rarely have validation, namely because application developers don't think of these as input. If we go back here, this is the way applications used to be. When the web server needed to talk to the database is just like, oh, the web server's talking to me, this has got to be good, because why would the web server lie to me? But when you're here and AJAX is making a request to the server and the server is just kind of passing it along to the database, if when you converted your application to be AJAX enabled, you've violated that assumption. Your database is still assuming everything it's get is going to be safe, it's going to be sweet, because why would anybody attack you? It's inside the application. But if your application straddles this internet cloud, I directly talk to them and I start screwing you up. So, I kid you not, I actually found this as a web service in the wild. It was a real application, one of these Web 2.0-y AJAX applications. And this is a function for the user to update their password. It basically takes in the username and the new password they want to use. It, interestingly enough, makes a SQL injectable string. So even if I didn't just simply want to reset everybody's password on your entire site, I could SQL inject you and dump the database out. Basically, it constructs it, sends an update statement, and the other thing is they're also cross-site scriptable, because I give you a new password, and what's actually being returned to the user is this text string, password updated to whatever you had, and that actually ends up being placed on the web page. So if I change my password to script alert or script port scanning piece of code, that's not going to execute. So this thing was vulnerable 3 different ways, and this was actually rather popular, and you guys would know it if I said the site, AJAX, or specifically an Atlas web app. So repudiation of requests, or as I like to say, I really didn't make that stock trade, trust me. So what is repudiation? This is something that has very specific meanings in cryptography. Specifically, you're looking at non-repudiation. In cryptography, if you and I have a conversation, after the fact, I don't want you to be able to say, nah, Billy, we never talked about that. I can prove to you that we did in fact talk about that. Well, with AJAX, you can't prove that anything happened. And here's why. HTTP requests from AJAX are identical to the server. These are 2 requests. The one on the left was made to Google Maps just to fetch the initial page. The second request was made by AJAX from Google Maps. You'll notice that it actually has the same cookie. The browser goes ahead, shoves all that stuff in for me. It's got the user agent, everything. From the web server's point of view, this is just an HTTP request. There's no magical header. There's nothing here that knows, okay, this was a request made by script on somebody's behalf, as opposed to this is a request made by someone actually clicking on a link. So this is very interesting. You can't prove you didn't make an HTTP request. In other words, JavaScript can now make requests for you for any type of resources. And because AJAX is so handy, yes? Yes, I'm sorry. That is a very good point. The refer, the reason that is different is that I actually typed in maps.google.com, and when you type it in, there is no refer because I wasn't coming from anywhere. Now, the refer lets you know that maps.google.com was the site I was on. But if I was on maps.google.com and I clicked a link to say, go to the About page, the HTTP